Okay, so this one is an example, and we won't be having a true length, right, in this kind of problem. And let's see how we're gonna solve the oblique problems without a true length line given to us. Yeah. So let's see. Okay. This slide is kind of messed up. Let me make it a little bit looks better. Yeah. I have no idea what this is either. So just weird from last professor. Well, I don't know. Just I'm gonna just fix it a little bit here. If you have it in your PDF, sorry. If I have time, I will change it for you. Okay. Um, okay, so let's take a look at the yes, how to solve the oblique auxiliary views problem without the true length line. So like we said, right, 2 sections ago, so every time you don't have a true length line given to you, yeah, we're gonna solve in two different methods. So now we're gonna get into the first approach, yeah. If you have a true lines, then we use the true lines to go from the secondary auxiliary, yeah, the problems, and we go with the middle view, and then your primary, we use the primary and the secondary views to get to to get to the true size and shape of the last view. Yeah. All right. Example 1. So we don't have a true length line in our problem. How are we gonna solve it? The first example is showing you the first approach. Of course, we have two approaches to deal with a problem without the true length line. Okay, so if you don't have the true length line or not apparent, yeah, to your sight, what we're gonna do is we usually draw a full line. We always start with a full line anyway, yeah. But this time that full line gotta be, yeah, parallel to any defining boundary, all right, or boundary line on the surface. Okay, you will see it in the diagram, yeah. So don't worry about it right now. Just reading, and then you're gonna project that perpendicular to the new full line. This is about the same, yeah, only this is different. So we'll follow the same construction method we did, yeah. And then create the new view. So in that new view, the line, right, that was originally selected to parallel with a new full line is going to be displayed, yeah, in true length, yeah. So let's take a look at how this approach works. So we've got two adjacent, right, views. Same triangle, of course, your front view and then your right side view. First, you always do what you do. Is that incline or is that the oblique planes, yeah, that you're dealing with in this problem? Now you look for the edge line. There's no edge line, no edge view, right? So therefore you're dealing with most likely oblique surface, yeah. Then you gotta think about, well, if I project it to the top line in your mind, would it produce an edge view? It can't, right? This is to sort out, yeah. Then you look for the perpendicular line to the first full line, yeah. You don't see it because even if you put here in between, yeah. Let's try to imagine we're thinking inside of our head, and here is, yeah. I'm just gonna roughly draw a solid line right there, but you know that that is a full line, okay? I'm not gonna go with a little two dot here, and none of them is, yeah, parallel to this full line, yeah, even if you draw the perpendicular to point here, of course. So we don't have it. So definitely you're dealing with your true line is not given to you in the problem, yeah. Okay, so the very first thing we will do the same thing. We're gonna start with the projectors, yeah, points. So your points, in this case, we go 1, 2, 3 here. So therefore, give the corresponding point like that, and then extend your projectors, yeah, from point to point, corresponding points. And then we're gonna throw this full line, but this time just throw it, you know, at the edge of this the front view, okay? because why do we do it? Because you need to project this thing, okay, to the next view. So therefore we have to measure the distance, in between these points. So therefore we usually use this approach by stick this full line to the edge of it. Okay, we'll go that way for dimensioning. Okay, so here now we've got the full line, which is our reference plane, and we will be, of course, dimensioning, from this line to each point. So from here to 2, from 3 to 3, and then from here to 1. Okay, and we'll do the same thing, of course, in our primary auxiliary projection, which is going to be on this side. So now we're gonna get started, right, with our middle view, which is this guy. So the first full line is this distance away from point 2. All right, now I have my point 2. So you gotta go that distance to the second full line. So this distance to the second full line. That distance away from point 1 to the full line. Okay, so therefore we're gonna do the same thing. The point 1 got to be that distance, away from the full line, and we do the same thing, right? This 3, all right? Point 3 is a change of view, all right? This is, don't forget, you are looking at it, front view. This one is your right side view, all right? So you have your object behind it, and you are looking this way, yes? So therefore your point 3, okay, it's on this side instead of that, So this is where your brain have an issue, okay, when you draw the dimension from it, okay? So how we seeing it is we are injecting our right side view, which is on that plane, okay, away from that reference line, okay? So your reference line, which is this full line, second full line, see that is on the side of this right side plane, okay? So that's a little bit tricky when we have to look the front view and the right side view, and even if we're drawing into it or into the surface, right? It looks like it's on the surface. So trying to see it with your intelligence into the surface, okay? So this is into the surface, so our projection is going to come on top of it, So let's see like how we connect it. Now it just see how it go up, in your vision. When it was there, it's really difficult for you to be able to see this reference line is actually raised, So you gotta pay attention to this and make sure you put arrow, where how you're dimensioning, in which direction this is going up, up from the surface, okay, from the plane. So practice that, even if I tell you you can't see it, this need a lot of work to do by yourself in order for you to get a mean drawing yourself, So now you got it, okay, and this is your true line right there, your distance are kept, This is difficult to see because that's your right side, okay, that's your right side, and there's a distance, particular distance. In here you see only a point you can see behind, because you're looking at it from the front view, and this is a side view, and from the side view we're getting the top view out of it, okay. That's a little bit difficult, and I've got Raisor up, okay. We keep the kind of like orientation can deceive your view, your eye view, because you think like it's kind of distorted, it doesn't even look like they have the same size, but they do, it's just that you can see this, you can see this view from the front or the right, it is the same object, by the way. So now why do we call this TL, right? This 1, 2. a true length because it's been projected from the line that is parallel to the full line. So you gotta find where's the parallel line. I don't see it. So it is here. See, line 1, 2, your reference full line, and that's parallel to this, and this comes from that, from this, right, distance. So second full line, reference line, is parallel to line 1, 2 on the right side view, okay? And the projection coming out from that line, which is this guy, is your true line, okay? Train your eye to be able to spot, all right, these details. Okay, then the next one we're going to project, right, to the second auxiliary view. So let's see. So this is our first auxiliary view, that's our middle view, and we are going to attempt to get from this true length line to our last view, which is our top, right? And we call also that the same view, the secondary auxiliary view. We do the same thing, projection, okay? So here are your projector lines right there, extend it out, point 1 to 1, 1 and 2 on the same line, so you get a dot. All right, your point 3, okay, you're going to extend it out, again, the same thing. And here is your reference line. Keep the distance, right, the same distance from here to here, from here to here, yeah. A reference line to 3, reference line to 3, okay. Your reference line is parallel to that, yeah. Don't forget the depth of it, yeah. Now, I'm going to extend out because we need our view on this side of the reference line. And this is our first edge, yeah. You always have an edge view after you got your true length line, yes. So that's our first edge, your point, and then 3. Then we're gonna extend it out, yeah. Your full reference line, yeah, between the edge and the last view, 1 and 2. Expand it, 1 all the way to 2. Keep the distance, yeah. And 3, extend to 3. You gotta keep that distance, the same thing. Already show you how to do it. Keep the distance from here to here, same. From there to there and from there to there is the same, yeah. Connected. So here we go. That's your last, your top view. And that top view is your true size and shape, yeah. Coming out from the edge view. Edge view is produced from your true length line. We didn't have true length line, therefore we gotta made it up, yeah, by getting a parallel line to one of the edge, yeah, of your middle view. And that second reference line come from the first reference line by keeping the same dimension. Going from here to here is difficult because of the view front, and that's your right side. And you gotta consider the depth, right, behind these this edge, okay? So it got raised instead of flat like this. So going from here to the first parallel line to your second full line is very important for you to study this problem. Please go slow and carefully, okay? You can't jump your thoughts in engineering, technology, or drafting, of course, in this class, technical classes, all right? You can't jump your thoughts. Your thoughts got to be very organized, and we think step by step, okay? We don't think or jumble up, yeah? So leave your home thoughts, yeah, behind, and don't complicate, okay? We simplify everything that we do in STEM. We simplify including our thoughts, yeah. Otherwise it would be very difficult for you to see them, yeah.